All right, great. My name is Brooke Anderson. My co-author for this is Dirk Edelbudel, and I'm going to talk some about using self-hosting a R package through drat for a large data package. And the use case for this is a study with hurricane exposure data. So let me start by talking about the motivation for this. I'm an environmental epidemiologist. Is that me? And I'm leading up a study on hurricanes and health in the United States. So as part of this, we collected all this exposure data on hurricanes at the county level, which is the level that we have the health data. And we did it, this is a multi-hazard, so we did it for a lot of different types of hazards: rain, wind, floods, tornadoes. And it's a nice data set, so I thought it would be very convenient to share it with other people. Our packages are a great way to do that. And we also came up with some different tools to use for it. So here I'm showing some examples of mapping. You can also pick out, you can say for Miami, pick out all of the storms within a certain period. So the idea is kind of simple. We're just trying to get this hurricane exposure data out there and some tools to use it, but it naturally splits into two different packages. There's a large set of data, right, and then there also are the code for the functionalities for mapping that and picking out exposure events and all of that. So I've split this up into two. On the right-hand side, sorry, it keeps automatically advancing, I think. On the right-hand side is the code package that we had, and that was pretty straightforward. It's not a very large package. The other part is the data package, and on that left-hand side, I've showed the tracks of all of the storms that we included in this data package, and it turns out there are quite a lot of storms. Not all of them are severe, but quite a lot that affect the United States. So it turned out to be a fairly large data package, and it was over the size limits of CRAN. So we decided to host that using drat, some of the tools in the drat package, and at this point there became two challenges. We wanted to put the code package on CRAN so it was available to users in the typical way. So we have that first challenge of putting the data package, hosting that through drat, and then the second of trying to connect a package on CRAN with a package that is hosted on a repository using some of the drat tools. So I'm going to break the talk up into these two parts. I'm going to talk first about that first challenge and second about the second, and I'm going to take a little break in the middle and tell a story about how wonderful the R community was and how I saw that through some of the work on this project. All right, so it turns out that R package repositories are not terribly complex. It's just a directory that needs to have a certain structure, and it needs to be network accessible. So here on the right-hand side, I've shown the directory structure that we used in our example. The things in black are things that were required. The things in blue were things that were optional. So you can see that there was a subdirectory in here that had a lot of the source code. It has the built package code, and you can put in different versions of a package. So this has two versions of the hurricane exposure data package. You can also put in compile code if you want. So this is showing an example with some of the Windows code. And also, if you want to kind of gussy up the front page of your repository, you can put in an index.html in that, and you can make that a little bit fancier. You can see at the very top of this, I mentioned this needs to be network accessible so users can get your package. In my case, I did that by putting it in a Pages branch of GitHub. And I'll talk a little bit more about that in a second. In terms of using drat for helping out with this, there's some excellent resources in terms of the vignettes, so I've put links through to some of those. So how is it different for a package user and for a package maintainer having a package hosted through your own repository using tools like drat? Well, for a package user, it's really not different at all. The user needs to tell R the address of this other repository, but after that, everything works very similarly to if you were hosting this on CRAN or something else. I'm really sorry that we keep skipping through. I don't know what's going on. Maybe if I made this. Okay. So you can tell R about the additional repository if you're a package user through the repos argument and install packages. You can also set another repos in options, or drat has a helper function called add repo that you can use for that. For package maintainers, there are a few extra steps. You need to start by creating that directory structure. And making it available to users. And there are a lot of, yeah, just take it out. Yeah. Okay, there are a lot of functions in the drat package that can help with the initial setup of that, and then also maintaining the repository. So you set up the repository, but then you need to add in new packages and update packages that are already there, so it has some functions for that. All right, you don't have to use GitHub to make that private repository to put it up on a network, but it is very convenient. In a lot of cases, it might be the best choice. It's easy to do this on GitHub because every GitHub repository has its own optional web presence through the GitHub pages, and you can take advantage of that. And then if you name that repository drat, then that is a unique name that every different GitHub user can have. And drat takes advantage of that some by allowing you to do shortened versions. If somebody set up in kind of the standard way of naming that repository drat, then you can just do add repo with the person's username. So my GitHub username is GEAnders. Somebody could tell R that they want to use my repository just by doing add repo GEAnders. All right. So that's done kind of that left-hand side of setting up the data package through a drat repository. So now the second step is connecting a code package. So I have a code package I want to put on CRAN, and it needs to use that data package that's on drat. How do I make that connection? So up to this point, just to fill you in, we were using some of the tools that Dirk has created, but Dirk wasn't involved in this project yet. There's really nice documentation for drat. We used all of that, set everything up. But at this stage, I was having some troubles making this connection. And so I'm going to take the brief break here to talk about how wonderful the R community is and my experiences in this. So for those of you who have not recently used tried to figure out software in other languages or software other people built. This is an example email that I got from tech support that was not R. So in this case, we were trying to do some grant reporting through software that our university had bought, I guess, and all of us with Macs were having problems with it. And we went back and forth a little bit, but eventually we got this email. It's out of our area of expertise to do deep level troubleshooting, in this case on all of the Macs that were having the problem. Maybe just borrow somebody else's computer, and that was kind of the end of it. On the other hand, R, I think, is just so wonderful in terms of being able to figure out and extend your software. So first of all, it's open source, of course, has always been open source, but now all of CRAN is mirrored on GitHub, and a lot of people put up stuff that's in development or stuff that doesn't go on CRAN. So you can always start by searching on GitHub, which is what I did, to try to get examples where other people had done this successfully. And I don't have very complex programming problems most of the time, so usually this is enough to get me there. In this case, I couldn't do that, so I ended up sending out a tweet with #RStats, asking for a little bit of a pointer for somebody to help me get the rest of the way. And the short answer, I immediately got back some helpful information. The short answer was that you can't do an imports for something on a non-mainstream repository, but there are some ways to kind of get around it. And Dirk sent direct messages, and within about 10 messages had laid out an outline of how we could do it, and then over the next week we hammered out and got out the package with all the details. Now in retrospect, I realized that I could have done this even better. If I put it up on R help or Stack Overflow or something like that, other people could go back and read those conversations later. But in a bit of redemption, we ended up publishing this and putting all of the details in a paper in our journal. So the full record is out there if you want to get all the gnarly details of exactly how to do that. We've now put that out. All right, so the answer, how hard is it to make this connection? It turns out it's not very hard. There are just some details here and there you need to kind of put in. So the description file in an R package has a field called additional repositories, and using a drat repository, you gonna try to help me?
It's already set for the lightning talks.
Yeah. You must be on R. That was very good tech support. All right. Indeed, yes. So it turns out it's not very hard, right? There's this additional repositories field, and so you can put optional packages on that. You can't put required packages, though. You can't put any packages that you're linking with imports depend or linking to. Those all need to be on mainstream repositories. But to kind of get around that, you can use suggest with the optional package. You just need to make sure that you take care of some details within the code. And there are two main aims here. First of all, we were trying to make sure that we passed CRAN check with the code package we were hoping to put up on CRAN. And then second, we wanted to make sure that the package behaved nicely for the users. All right, so in terms of details, there are three basic jobs that need to get done with the code that you add. The first is adding some infrastructure in the description file. Second is customizing behavior when the package is loaded. And then finally, conditioning some of the code in the package on whether the data package is available. So I'll walk through each of those very quickly. For the infrastructure, as I mentioned, you can put the name of the data package in suggest and then put the address in additional repositories. So I put in the 2 lines here that we added into our package that went on CRAN with suggest pointing to a certain version of the hurricane exposure data, and then additional repositories gives the address to my GitHub repository. Next, you need to customize the behavior when the package is loaded. So when the package from CRAN gets loaded, it needs to check to see if the person has the data package available and act in one way or the other, if it does or doesn't. These steps can be put in what traditionally people often put in the zzz.r file. You don't have to use that file anymore, but people often still do. And you can do that by writing onload and onattach functions to handle this behavior. You can check if the data package is available and then create an environmental variable that's a Boolean of whether it is or not that can be used to condition code that comes later in the package. And then if the user doesn't have the data package, again, we want them to realize the error easily. So you can give a message about you're missing a package that you're going to need for a lot of this code, so you probably want to stop right now, go install that, and then try again. Within the code, for our example, almost all of the functions are working with that data, so the package really doesn't do much if you don't have the data. So we went through, and for most of the functions, we conditioned it on having access to the data, where if somebody did not have that data package available, it would if they tried to run a function, it would very quickly give out a message saying you need to stop and go and get that data source. But we also conditioned code in the documentation examples and the vignette to also look and only run if that was available. We could have made those totally static using don't test and a static vignette, but in that case we wouldn't have had that step of testing when we were working on it on our own systems. So instead we conditioned on whether somebody had it or not. And here is a brief example for doing that in the vignette. We put this as the first code chunk in the vignette where we used require namespace, and we ran it with the quietly option set to true to check whether somebody had access to that data package. And then if they didn't have that access, we used knitter's options chunk set method to set eval to false. This set the evaluation of all of the code chunks throughout the rest of the vignette to not run. And then so somebody wouldn't get confused if they tried to do this, we also, again, put out a message saying why they weren't going to see anything running later in it. So once we did this, we didn't have problems with CRAN checks because CRAN wasn't trying to run all of that code with the examples, but it still ran on our system, so the vignette built on our system. And it's the vignette that's rendered on your own system when you build to submit to CRAN that's the one that users actually see. So users got the version that we wanted them to. If you'd like to find out more about this, as I mentioned, we have an article that came out in the latest R journal. If you're like me and you like looking at code examples, we've got both of those packages up through my GitHub account. Drat, as I mentioned, has excellent documentation if you're trying to do that step. And then I just wanted to finish with some acknowledgments on Martin Morgan and Roger Ping. Both gave us some really good suggestions as we were kind of hammering out the details of this. And then also the Hurricane project itself is funded by the NIEHS. I wanted to acknowledge them. All right, that finishes it.
There's plenty of time for questions.
Yeah. Size. It was purely size, yeah. It's a great question. Yeah. Yeah, that's certainly an option. And I think if I had a really, really large data set, I might have tried to set something up where there would be an API and then the package was just working with an API. In my case, I'm much more comfortable coding stuff up in R than hosting a lot of stuff on the web. So for me, this seemed like an easier solution. I also like if you have something that's large but still manageable. I like the idea that you can do version control even for data. So this, having it up as a data package, I could put in the help documentation for all of the data in a typical R format, and then I could also make sure that I have some version control on that, even if it's something that I'm doing myself.
Yeah, what you suggest is basically the old school way of doing it, and we have a reference to that in the paper because I think Roger had a package doing that and some other people did that. That's sort of old school, you put it on a server, but if you think this through, the one thing that we're getting really, really, really right in the R ecosystem is getting access to different components through packages. And that's what we're doing here. The installation basically is quasi-automatic, it gets resolved, you know, you can it in different places, so that's why having it in a package seemed to us preferable to these other means of going to a single server where you may have access control and other. And then sort of two more to Barry's question. So there's you got to draw a line somewhere in the sand. So CRAN does one, it's 5 megs. If it's larger, you can't have it on there. And then something like this arises. So we have that sweet spot. And the upper bound is 100 gigs, I believe, when GitHub tells you to. That's sort of nice, but you're having a free resource here, so please don't do that. So we have a note in the paper. Again, going back to Bioconductor, what they do, because they have data sets that are larger, and their mechanism is to then actually go to LFS, large file store, and put the burden on the submitter rather than the community to pay for the data store. And those are sort of all reasonable attempts, but by 80-20 rule, we have a really nice sweet spot because there's a heck of a lot of interesting data sets that you can have between 5 and 100 megabytes compressed. And then this mechanism just works by using our infrastructure. I mean, we basically just laid out how that works. Sort of that stuff's all there.
Yeah.
Well, that's the thing. It could if we put a new version on. If we vintage it or if we fix it, and because that's what the package mechanism does. Right? It sees a higher available version and it will pull it from there. If you have edited to your session,
Yeah, if you're.
which you may have to, I think your prompt doesn't see from the package. The package sees it.
I think that you'd get.
So
It's a good question. I think that you would have to, by hand, update the data package, do like update packages.
The thing that I do at work, where I'll get you in a second, where I basically have sort of 3 main repos now. I mean, I have CRAN, I have one that I host on GitHub for things that are not on CRAN, sometimes other, and then I have one that we have at work. So I always see 3 different repositories, and then it's a superset, and newer versions will be found in that. If you don't make the additional repository known to your session, then available packages doesn't see it, update packages doesn't see it, but it could. So you basically, you have to put it into this framework in which R sees packages and does a set diff between current and available.
Okay, I think that it's time to move on.
We're
Yeah,
done.
yeah.
Thank you. So I'd like to thank the speaker and co-author, please.